I recently bought an AVR Dragon, which is a mid-range programmer for pretty much any AVR chip you can think of. And I wanted to make this video kind of giving my first impressions of the programmer and also a short example of what you can do with it to try to help out anyone that might be thinking about getting it. So far, I've been really impressed with the AVR Dragon's capabilities. I've mainly been testing the ISP programming and debug wire. I would really recommend this programmer to anyone that's trying to upgrade from a dumb programmer that you can get off eBay or other sites such as the USB Tiny ISP or any other really cheap programmer you can find online. Also, I think this is a good programmer for beginners. It's pretty cheap, and if you think you're up to it, I think it's a great buy and can really get you pretty far. Alright, so now I can show you the hardware setup on my little example project here. In the middle, we have the Atmega 328p that I'm using as a target. And over here on the right, we're using 60 megahertz crystal. And then we have a red LED that I have connected on one of the pins. And lastly, I'm running everything off 3.3 volts from a 9 volt battery in with a regulator. So now let's head over to Atmel Studio and we'll start programming and debugging. Alright, so here we are in our Blink projects. Up here at the top of the code, I'll go ahead and set the frequency of the controller at 60 megahertz. And below that, I go ahead and set some dependencies for the rest of the code. And underneath that, I go ahead and make some little micro functions. And these are not really functions, but they kind of clean up the code and make it easy to read. And they just allow me to set inputs and outputs and set pins high and low, and they're actually implemented at compile time, so they're not really functions, but they're really useful. So here we have the LED pin defined, and it's port C3, which is pin 26 on the package. And down here in the main loop, we go ahead and set the LED as an output, and that just prepares for the actual loop where we're blinking the LED. We set it high, it waits half a second, and set it low, and it waits half a second, and that just blinks the LED. So now that the code's in there, we can go ahead and build the project. So I'm going to go up here to build and build solution. And hopefully, yep, we get build succeeded. So now we're built, and I'm going to go over here to device programming and check the tool, device, and interface. And those all match my parameters, so we're good. I'll hit apply. And set the ISP clock to, it doesn't really matter. Just make sure it satisfies that statement below. And I'll hit read on device signature, and it'll get the device signature and target voltage. And the voltage is correct. It's pretty much 3.3 volts, which I'm running at. Now I'll go down to production file and select my file. And you can browse over on the right. But this is my ELF file that came out of the build process. So I'll hit program, and it will program. So now you can see the LED is blinking just like we hope. So that's pretty much an overview on how you could program. And now I'm going to go ahead and try to start to get into some of the debugging things. So the first thing we have to do is set the interface to debug wire, which is right over here. We can go to interface debug wire, and it changes the tool up here on the right. And now we can go save it, and we can now set some breakpoints and prepare for debugging. So the breakpoints are set, and now we can go ahead and say start debugging. And sometimes this is a little finicky. Here's a little error. Yeah, it's just throwing some errors. I'll try it again. Alright, so we're getting a little bit more errors, and hopefully this time it asks us to cycle power. Yep, okay, there we go. So it wants us to cycle power, and I'll go ahead and do that. And I'll hit OK, and hopefully we'll actually enter debug mode. So it looks like we're in, I think. I'm going to go ahead and fix these breakpoints. They're a little bit broken over here on the left. So I'm going to just erase them and then put them back. Alright, there we are. So the yellow is where we are right now in the code. So the LED is high, and we're waiting to turn it low. So we're waiting on that output low command. So now when I hit continue, it should output, the LED should go low. So let me hit continue here. And now you can see we're low, and now we're waiting to go high. If I hit continue again, we should output high. There we go. And I can keep doing this. I think you get the point. So this is really useful for just viewing variables and viewing actual hardware pins like this LED. You can see what's going on. So you can also go over here to the IO view window. And if you don't have this, by default, it's up here in debug, Windows, and IO view. So just click that and that'll give you that window. And this pretty much just shows you everything that you would want to know about your controller. So I want to know about port C because that's where my LED is. So I clicked on port C and we get 3 registers down here. The top 2 are some settings registers. And the bottom one is the one we really care about, which is the data register. So over here, I'm on bit 3 because that's where my LED is. And I can go ahead and click that. And it should change the state of the LED. So let's try that. There we go. So now it's low. I can turn it high, and so on and so forth. And you can see what that does. And this is really useful too, because you don't have to rely on the code to change everything. You can go in and manually try things without having to actually put things in code. And that can always be helpful when trying to find problems. But yeah, that's pretty much all I have for today. That's kind of where I've gotten so far with my Dragon, and hopefully it was a little bit of help to you if you're looking to buy one or just kind of want to know more about debugging firmware and like actually in hardware. So yeah, that's pretty much the video. Thanks for watching.